and supporting their pupils to make sense of mathematical concepts and ideas and not just follow rote procedures. And today I'm going to be looking at ratio and sharing with ratio. And for me, we often start sharing with ratio in the wrong place. Very often, the first experience that pupils have with sharing in a ratio is sharing a whole across the ratio. And actually, for me, and I'll explain why as we go through the video, the place to start with sharing a ratio is here. It's sharing with a ratio when a part is known. So you can see here we've got the problem. Tom and Hannah share some money in the ratio 3:5. Tom gets £24. Work out how much they share. So we're starting with knowing one of the parts. And like I say, I'll come to why I think this is the place to start in a little while. But for now, let's just tackle and have a look at the problem. Tom and Hannah share some money in the ratio 3:5. So we want to be looking at that ratio 3:5, and sort of a standard visualization for something like that would be a bar model. And you can see what I've got here is I've got my Cuisenaire rods, which can be used as the sort of physical manifestation of the bar model. So if you're wanting to actually work with bar models in a concrete form, then Cuisenaire rods are probably the go-to manipulative for this. And so what we're going to do here is we're going to just look at this ratio 3:5. And this is what I would get kids to do if I was sort of working on this in the classroom. I'd say, right, we've got this ratio 3:5. Show me 3 and show me 5. And I'd expect them to bring out the 2 rods that I've highlighted here. Not the only 2 rods we could use, of course, but they are the smallest rods that we could use to show the ratio 3:5. And so I get them to show me this, and I'd say, right, so which one's Tom? And Tom is the green one there because he's the 3. And which one's Hannah? And Hannah is the yellow one there because she's the 5. And so I would say to pupils, okay, well, imagine that green rod is worth £24. What can you tell me? And, forgetting about the problem for a minute, work out how much they share. Just what can you tell me? If this green rod is worth £24, what can you tell me? And here's the second sort of thing that I think that we don't do as well as we could do in this country all the time. And that's about focusing on the multiplicative relationship between the rods. And if you've not watched my ratio and fractions video, then I would suggest you watch that at some point as well, because it really drills down into the multiplicative and fractional relationships within ratio, both part to part and part to whole, and why all of those are important. And so what I'd be looking for here is, rather than sort of the standard strategy, which I might use for some pupils, depending on how good their fractional multiplication is, rather than the standard strategy of being able to tell me, if this is 24, then 1 square is worth 8, or the white box would be worth 8, and the 5 rod is 5 times bigger, so therefore it'd be worth 40, which is fine. And potentially if kids' multiplicative reasoning skills aren't 100% there. But what I'd be looking for in this case is for pupils to be telling me, well, this is 5/3 the size of that. Yeah, this is, to get from here to here, I'm going to multiply by 5/3. Or alternatively, and equally as good, well, 24 is 8 times bigger than 3. And so the value of this must be 8 times bigger than 5. And the reason I want to highlight and get kids recognizing both of those, and hoping kids tell me both of those, is because that mirrors then the 2 sort of relationships that exist with any ratio or proportional situation. And when it comes to sort of showing that in the abstract, then I'm going to use one of my favorite devices for exploring ratio and proportion. I'm going to use the ratio table. So here's my ratio table for Tom and Hannah. And we know that Tom and Hannah have shared this money in the ratio 3-5. And we know that Tom's is £24. Okay. And so we could potentially, if I can do this right, add a label here. Maybe not. Okay. I'm sure there is a way to do that. I just can't remember how to do it because normally I'd just be on a whiteboard writing it. But we could add a label here for £24. Maybe if I actually add a 3 rod with the label 24. No, that's not going to work either. Okay. That's fine. But yeah, normally I'd just write that on a whiteboard and that's the 24. But then again, sort of coming back to the rods or the ratio table, what I want to see here is I want to see those two relationships. I want to see that, this is 8 times bigger. And so this is going to get 8 times bigger. What we typically might call here the scalar relationship. Yeah, this has been scaled up by a factor of 8. And so this has been scaled. This will also be scaled up by a factor of 8. But I also want to see what we might call here the functional relationship or the exchange rate, the fact that across this table that Hannah's amount will always be 5/3 of Tom's amount. And so it doesn't really matter. And this is the sort of key to the ratio and why I want this relationship in particular. It doesn't really matter how much Tom has. That actually, whether Tom has £24, whether Tom has £36, whether Tom has £3 million, whether Tom has a number that isn't a multiple of 3, this number will always be 5/3 of that number. And that is the sort of key structural, functional relationship connecting those two. And so we can get that Hannah has got £40, and therefore altogether, obviously, they've shared £64. Now, I've concentrated on Tom and Hannah there, but actually there's no good reason for me to concentrate on Tom and Hannah. I don't really care about Hannah at all. What I'm interested in is Tom compared to the total, because I want to work out how much they share. And so actually what I could do here is replace that 5 with an 8. And why an 8? Well, of course, because I'm looking at this ratio and I'm saying, right, if I look at the problem, Tom gets 3, and how much they share is the total amount of money. And so what's the relationship between those two? It's 3 compared to 8. And we can see here, of course, that if we put the 3 and the 5 next to each other, that's the 8, which would be a sort of standard way of representing that ratio if I am interested in total, or indeed if I'm sharing total, which for me comes later. So I could look at Tom here, and of course, because I've chosen Tom, I'm going to have to write it all out compared to total. And say, well, Tom gets 3 parts in the ratio and the total is 8 parts. So I want to sort of ignore that 5. I don't really care about Hannah. And then Tom gets £24. And again, I can see the same scalar relationship now, that this still got 8 times bigger. And so this will still get 8 times bigger. But now the functional relationship between Tom and the total, because it's a different thing that I'm creating this relationship between, it's no longer between Tom's part and Hannah's part, it's between Tom's part and the total. Instead of being 5/3, it's now 8/3. And I think this is important for a couple of reasons. I mean, obviously here, no matter which way you go, it's going to get the £64. But I think this is important for a couple of reasons. Number one is, like I say, it's that functional relationship that exists in all ratio and proportion scenarios. You know, that y equals kx bit that we eventually come onto for ratio and proportion. This is the starting point here. And recognizing that this functional multiplier that comes across the columns of this table here is really important in motivating why that proportional structure y equals kx is even a thing later down the line. That is why, for me, this is the place to start with ratio, Tom, with knowing the size of a part of the ratio, if you like. In this case, the 3 part. The Tom gets £24, because it motivates that relationship between one part and the other part, between one part and the whole. Yeah, it motivates that relationship directly. Whereas, I mean, I could do that with the total and working that way, knowing the total. But for most students, we're going to start by examining the relationship between the parts. And so if we're going to start by examining the relationship between the parts, like the top one there, knowing the part rather than knowing the total is the way to start for me, because then you get that multiplicative relationship between the parts straight away, rather than having to add for the total or look at the total compared to one of the parts and things like that. Okay, so this probably actually wouldn't be my starting question for this. My first question would probably be something like, how much does Hannah get? Tom gets £24. How much does Hannah get? And working out the 40 and working on that. The reason I chose this as my example for you is because I wanted to be able to highlight the two ways we might do that with pupils. We could focus exclusively on Tom and Hannah in all cases and use that to work out totals or differences or however, whatever it is we're being asked to work out. Or we could form a relationship between Tom and the total. But it's this, I think, that is going to enable us to tie ratio to proportion and create that sense that these are two sides of the same coin here. Whereas if we, go down that unitary method of talking about, okay, well, if this is worth 24, then 1 part is worth 8, and so 5 parts is worth 40, or 8 parts is worth 64. I think, although it's a great approach to think about in terms of rate of change and unit pricing and things like that. So it is an approach that people should see, and it's an idea that people should become familiar with. I think if we want to tie it effectively to those later things, we do need to be working on ratio like this directly from one part to the other part or one part to the whole, using that functional multiplier. So that was my short video on you sharing with a ratio when a part is known. As always, big thank you to Johnny Hall and his incredible website here, mathspot.com, that I'm using to create the manipulatives and the representations for these videos. If you're interested in manipulatives and representations, then do check out Johnny's site. And in fact, even if you're interested in other things, Johnny's site is fantastic. You can see we've got all the manipulatives and representations there, but we've got loads of other support for maths teachers here. There are different question generators, different starter tools, all sorts of loveliness. And if you are also interested in representations, then you might want to check out my website. My website is visiblemaths.co.uk. Although it says Peter Mattock - you can just type visiblemaths.co.uk. I have got lots of things there about the different bits that I work in, including my book, my first book. There are 3, and the 4th one is on the way. But my book, Visible Maths, not .co.uk, that's the website, Visible Maths, the book, which is all about using representations and structure to enhance maths teaching school, how to use those manipulatives effectively, including, as you can see there, a version of the ratio table. So that was my short video. I hope you find it useful, and thank you very much for your kind attention today.